Well, good evening. I hope everyone's doing all right. I hope you're coping well with the heat. I'm certainly not. I mean, down here in Swansea, it's what, 30 degrees? It's ridiculous. I can't cope. Anyway, enough about the heat. Today, as you can see on screen, we'll be using a website called Three.js.org/editor. There it is off into chat. And the brilliant thing about this website, if I just load it up here, is it is a 3D game engine. Well, not quite. In technicality, 3.js is a framework, but we're not going to worry about using frameworks. We're going to just use this sort of engine part of it. And yeah, today we are going to make a small little prototype, nothing large, just something that covers the basics. We're going to make a dungeon crawler. It's a very old kind of game. No one really makes a dungeon crawler anymore nowadays, not a first-person one. But let me just introduce you to the interface a bit. When you load up Three.js.org/editor, you get this plane in the middle, this grid. You can always rotate it around using the left click. You can zoom in and out with the mouse wheel. And you can what's known as pan around with the right click. You can move the camera. It's always useful to remember which click does what, because when you're designing 3D stuff, it's very easy to sort of get lost in your own design. You're a bit confused as to where you are. So, yes, what are we going to do? Well, let's start by creating an object first, because once we've got an object, we can start messing around with it. We can even attach some code. So I'm just going to go up to Add. There's a drop-down menu in the top. And we can see we can add groups, we can add boxes, cylinders, dodecahedrons, planes, rings, sphere, sprite, all sorts. I'm going to lay down a plane. This is just a flat floor. So I click it once and it's given me this multicolored thing here. If I zoom in, I've got what looks like a kind of plate. It's invisible on one side, but it's black on the other side. This is going to be the floor for our game, and it's going to make sure that none of our characters fall through. So let me explain a little bit about axes. Usually in a 2D game engine, you're working with two axes. You're working with X and Y. But of course, we're doing 3D, which means there's a third dimension, which means we also have Z. Now, in this case, X is the red axis, Y is the green axis, which is the one from top to bottom, and Z is the vertical, I don't want to say vertical, the second horizontal axis. There's two of them. Now we've got X and Z. And if I click on one of these lines, the red one or the green one or the blue one, I can actually move the plane about. So I'm moving it along the X-axis here. I can move it along the Z-axis. And I can move it along the Y-axis. I'm going to just press Ctrl Z to undo that because I want it right bang in the middle. Now, if this is going to be our floor, it's a pretty terrible floor. I mean, unless you like walking on the side, that's not very useful for us. So I need to rotate this around. And I can do this in two ways. In the top left, there's this control bar, and the second option down there is the rotate tool. And this brings up what is known as the gimbal. And this allows you to rotate something in whichever axis you want to. So if I rotate it in the X-axis, it means it rotates around the X. And if I rotate it in the Z-axis, it rotates around Z. And the same for the Y-axis. I'm just going to undo that. If I want this to lie flat, I want to rotate it by 90 degrees. So I could just click and sort of try and get it as level as I can. Or I could look over in the right-hand side to the Properties panel. And this contains all the properties of the object that you're editing at the moment. So I'm editing plane. We can see we've got this rotation option. And we've got three numbers here. This one represents X rotation, I believe. This one represents Y rotation, and that one represents Z rotation. So if we want to rotate it in the X, we need to type our number in there. So let's say we want to rotate it 90 degrees X. I'm going to type in 90 and press enter. Oh, and our plane has gone invisible. We really want the black side, so we've got this upside down. So I've gone the wrong direction. Rather than going 90, I should go minus 90. And it has black side facing up. That's going to be our floor. Okay, it's a little bit of a small floor, so let's make it bigger. We can do that with this scale tool in the top left. And we can drag each of the dimensions, so we can make it longer in the X dimension. We can make it longer in the Y dimension. We can make it, well, we can't do anything because it's a flat object in the Z dimension. But again, if we want to, we can just use the properties panel and type the numbers in directly. So let's make it quite large. Let's make that 100 in the X. No, that's done. That's not. There. 100 in the X, and there we are. We've got a very nice, massive floor. Okay. Remember, right-click to pan around. Maybe 100's a bit too big. Let's try 30 instead. Yeah, that's much more manageable. Let's change it from black. It's a bit miserable. Let's go to Material. And we can see we can change the color here. And it opens up the color dialog. Let's make it a kind of teal. Will teal work? Maybe. But yeah, it's still black for some reason. Even though we've changed the color, it's still black. And that's because in a 3D game, you have to think about the lighting. When it comes to designing stuff in 3D, you can only see something if it's lit properly. If there is a light bulb or a sun or a lamp or something in the 3D space. So to do that, I'm going to go to Add. And I'm going to scroll down and find, let's do a directional light. Ambient light lights up the whole world, which is quite nice. But directional light is a bit like the sun. It will light things up, but it'll also cast shadows. So I'm going to add a directional light. And we can see that it's created one for us. Okay, so this bit inside the axis controller, that's the light itself, and the line coming down is the direction of it, and we can see that it's casting light to the middle of the plane. Let's give it something to make a shadow of. If we go to Add and just add a box, we can see that the box is halfway sunk in the floor. Let's change that. Let's just move it up in the y-axis a little. And we can look at this box and we can see that 3 of its faces are in the light and another 3 of its faces are in the dark. And that's because the directional light is casting a shadow. And if I click on the directional light, you can just left click to get those. I can move it around and we can see that it changes where the shadow casts on the cube. Let's have it. Yeah, of course, the lower it is, the longer the shadows are. And the higher it is, the more direct the sunlight is. Let's just leave it at that. We're not going to use the light too much today. Okay, so we've got essentially a very basic scene. We've got the very beginnings of a game. So if I wanted to make a maze, how would I go about doing that? Well, we've got a cube. Well, you know how to make a cube. How do I turn this cube into a wall? Well, first of all, if I want it to be a wall, it should be a lot longer. So I need to scale it in a certain direction. What I'm going to do is I'm going to go to the Scale option and change it to the Scaling tool. And I'm going to make it a lot longer. Let's say that long. And that is the first wall of the maze we're going to make. So what can I do now? Well, I want this to go along the edge, so I'm just going to move it over to the edge. And we've got a wall. Now, I only found this out through experimenting, but this isn't tall enough to be a wall. Imagine we've got a person running around. That's quite tiny. You can see over it. It doesn't make for a very good maze. So we're going to make it taller. I'm going to go back to the scale tool, and I'm just going to make it a bit taller in the Y direction, and then go back to the translate tool. When we move things around a grid, that's called translating it. Nothing to do with Spanish or French, but yeah, we just call it translating it. I'm going to move it up so it sits nicely on the edge. Okay, once we got that, we can give it some color. So if I make sure I've clicked on the right box or the right object, I can go along to material, and I can go to color, and I can make it awful color. Let's make it this horrible orange. I like horrible orange. There we are. Oh, doesn't that just look foul? But we now have a wall. Now let's add 4 others. You can't copy and paste in this engine, but you can go edit and clone. And it's given me a second box, and if I just use the translate tool, I can do that. Let's edit and clone again. Let's drag it out, and we need to rotate this. And we need to rotate it 90 degrees, but look about which axis we need to rotate it. We want to rotate it about the y-axis, so we need to change its y rotation. So I could go to the rotate tool, and I could change the green one, which is y. But that's not very accurate. So instead, I'm going to make sure I've selected it. I'm going to go into the Properties panel, select Object. And where it says Rotation, I need to change the y-axis. And remember that these numbers go in the order of X, Y, Z. So I need to change the middle one. Let's change that to 90. And as soon as I press Enter, we've got another wall. And then I can translate it in the Z axis and put it there. Let's do the final one. So, edit, clone, and move it over there. So what we essentially have is a very basic maze. I mean, it's not a very complicated maze. In fact, it's just a room, really. But let's get our character walking about the room first. Now, I could spend the next year or so talking about how you can animate a character, you can have inverse kinematics, you can have all this fancy stuff. That's a little bit too involved. So instead, we're going to make our character, and we're just going to choose a shape. So we can have our character as a box, we can have it as a cylinder, an icosahedron, an octahedron, a ring, a sphere, a sprite. For fun, I'm just going to make my character a donut. Let's zoom in on that. Yeah, I've got a donut for a character. I'm just going to move them up a bit so they're not sunk into the floor. This is going to be our character. So, how do we know this is the character? Well, this is very important at this stage. We need to give it a memorable name. And we need to give it a name because whenever you're programming, I always mention this, things have to have good, significant names so you can always refer back to them in the code. So if you make sure you click on your character or whatever shape you've chosen for that, we can go over to the Properties panel, and where it says Name in the Object tab, I can change this to be something that I'm not going to forget. So this is my player character. So let's call it, I don't know, character. And now this is known as character. And, well, I'm not going to forget that. Now, with character selected, we can start adding our code. So how do we do that? Well, you'll see at the top of the Properties panel, there is this list of everything that you've got in your game world. So we've got a camera, that's what we're looking through. We've got the scene, which is everything in it. We've got the plane, remember that's the floor. We've got the light, and we've got all 4 walls. And finally we've got the player, the character. Now, if I'm writing code that's going to apply to the whole level, I need to write it inside the whole level. So I would like you to select scene, and we're going to add code to scene. And to do that, I'm going to make sure scene is selected, and I'm going to scroll down in the Properties panel, and at the very bottom of the Properties panel, in the Object tab, there's a button labeled New. And that enables you to create a script, and that's what we want. We want to create a script. So I'm going to click New. And it's a bit hard for me to see. I hope it's coming out all right on your screens. But there is now a box there where I need to give my script a name. So this is going to be the logic for the whole level. So I'm going to call it, I don't know, level logic. And once I've typed that in, I can click edit. Sorry, I can press enter, then click edit. And it brings me to the code editor. Let me zoom in on this a tad so it's easier to see. This is where we write the code to control the game. The very first thing I want you to do is delete everything that's there. We want to delete this function update. We don't need that. Function update, anything that's inside this function happens every single frame of the game. So if a game runs at 30 frames per second, update is called 30 times a second. If a game runs at 60 frames per second, update is called 60 times a second. We don't need to do anything about that. We can just delete it. So I'm going to highlight it all and just get rid. Not needed. What we do need, however, though, is we need something that lets us talk to our character, to our player. And if you remember, mine is a donut. So, how do we do that? Well, I can't just call it by its name. That would be easy. And, the one thing about programming is we do like to make things difficult for ourselves. So I need to give it a new name on top of the new name that I've already given it. It's confusing. Let me kind of explain by doing. I need to make a variable. And the language that this is based in, which is JavaScript, we declare a variable using the keyword var. And you see, as soon as I type that, that's currently white text. That's white text. And as soon as I press R, it goes to pink, because that's a keyword. Ignore the red error at the moment. I'm going to put a space after the var. This is where I put a new name for my character. So I've already called it character. Can't use that again. Let's call it player. Now I need to attach a meaning to the word player. I need to tell the engine, the game engine, what player is. So I'm going to say player equals, and what I need to do here is I need to grab from the scene, I need to take the donut character. Remember I called the donut character, I've given it the name character. So how do I talk about the scene? Because we're asking the scene, hey, can I have control of the donut? Now, you'll remember that when we created this script, level logic, inside of scene. And in JavaScript and many other languages, when you're talking about something that we're currently programming inside of, we can reference it by typing this. So when you see this, it's talking about whatever the script is inside. And we can see that the script level logic is inside scene. So this is scene. This and scene are the same thing. And we need to ask from scene, what do we want? Well, we want access to whatever that donut is. And so we're going to use a function. We're going to get the object by its name. So I'm going to do this dot, and then I'm going to type in the function get object. Notice I use a capital O but a lowercase g, so object, then a capital B. And I don't want get object by ID because that's a long string of letters that no one remembers. I want to get object by name. Then I can open a bracket because I'm going to tell it what name I want to grab. And then usually in languages, you usually use speech marks. You know, I always go on about start speech mark, end speech mark, start speech mark, end speech mark. We're going to use apostrophes today just because JavaScript's awkward. It's annoying, but start an apostrophe. And now I need to give the name of whatever I called my donut. And I called my donut character. And I'm going to end it with a apostrophe. I'm going to end it with a rounded bracket. And because JavaScript is what's known as a C-flavored language, it's very similar to C, which is very old at this point. We end sentences and statements with a semicolon. So I'm just going to stick a semicolon on the end. Oof, lot of work. And all we've done is get access to the character. We've not done anything with the character. We need to actually get it moving about, get it doing something. So what we need is a function. Because what this engine, Three.js, does is it uses the event-driven side of JavaScript. Basically, when an event happens, we can then tell it what to do. So we need to sort of trigger an event. And we've already seen an event. We saw at the very start of this script, it automatically filled out a function for us called update. Now, update is an event, and that event happens once every frame. we're going to add in another built-in event that JavaScript has. And that event is called key down. And that's what happens when you press a key on the keyboard. This is going to be how we control the character. So I'm going to start by writing function, because it's a function. And the function itself is key down, all one word, all lowercase. And when JavaScript sees a function called key down, it will call that function every time a key on the keyboard is held down. So function key down, it has to have an open bracket, and inside here we have to write event, because this is an event. Now, with C-like languages, ones that are very similar to C, we can put everything inside a function as long as it's surrounded by curly brackets. So at the end of the function line, I'm going to put an open curly bracket and then press enter. We're ignoring the error for the moment. And this is where we can put our code. So we want some code to move the player around. That's nice and simple. In fact, all it is the name of the player. Remember, we called it by this variable player. So I'm just going to write player. And as soon as I press dot, oh, it's not done it. Never mind. I then put a dot. And then when I start typing, it suggests to me all the things we can do to manipulate player. So if I type rotation, I can manipulate its rotation. If I type position, I can manipulate its position. If I type, is material on? Yeah, I can change its color maybe. I can do whatever I want with it. I can do all sorts. Can I? Yeah. I want to get it to translate. I want it to move around, and I want to change what axis it moves in. So we're going to translate. So I need the keyword translate. And it's given me 5 options. I can translate on axis, I can translate X, translate Y, or translate Z. If we just duck out of this scene of the script for a moment, and let me return to the better zoom level. If I click on the donut, we can see the axis marker here. Remember, X is the red arrow, Z is the blue arrow, and Y is the green arrow, Z is the blue arrow, X is the red arrow. Let's say I want its front to be Z. Let's change it in the Z. If I go down to go back to scene and back down to edit of the script. Oh, it's deleted everything I didn't finish. Bums. Bear with me as I write it all out again. Function key down event. Okay, what I want to do is player dot translate. Let's zoom in again. And I want to translate it in the Z axis. So I'm going to write out translate, and then I'm going to put a capital Z after it, and then an open bracket and a close bracket. And inside these brackets, we need to tell it how much it moves. Now, I've been playing around with this for a couple of days. I know that you need to make it move very small amounts. It's all about experimenting. You might want it to move more, you might want it to move less, you might want it to move faster, slower. I'm going to try Let's do 0.5. As I said, quite small. That's the end of our JavaScript sentence. So, of course, we finish it with a semicolon. That semicolon is always very important, otherwise it starts complaining at us. And we've still got this error, and that's because we haven't completed this open curly bracket. We've opened a curly bracket. Now we need to finish one. So I'm going to press enter, and then I'm going to write a closed curly bracket, and it automatically puts it in line with the starter function. So we've now got a key down event, and every time a key is pressed on the keyboard, we translate the player by 0.5. And we translate it in the Z axis. Okay, let's close that. Let's see if this works. I'm going to click play in the bar at the top. And it should be that as soon as I press a button on the keyboard, our donut should move. And it does. Let me try again. It can be any key on the keyboard. Oh, I pressed Control. Shouldn't have done that. Yeah, there we are. Our donut is moving. You might notice you can't control it. It just moves in one direction no matter what you do. And in fact, yeah, it's gone off the page. Don't worry, we're going to get onto that. If I go back to scene, make sure I click on scene, and back to level logic, I can edit this script. I need to somehow work out what key is being pressed, not just any key on the keyboard. I need to say what key in particular. And this is where we get on to a slightly unfortunate thing about JavaScript, in that it doesn't just do something simple like if A key is pressed, do this. If Z key is pressed, do this. If K key is pressed, do this. No, it does something very annoying, and it has a key code. You can't just say A, B, C, etc. You have to memorize a number for every key on the keyboard. It's frustrating, but we'll deal with it. Where it says player.translateZ, I don't need that at the moment. I'm going to change that out and put in something else instead. So I'm just going to delete player.translateZ 0.5. And we're going to start our key down event from scratch. First things first, I need to grab the key code. And the key code is stored in that variable there, event, that word there. So I'm declaring a variable, so I'm going to write var, because it's a new variable. And this variable's name is key code. What is key code? Well, key code is equal to whatever's inside event. We need to grab something from event. So I'm going to say var key code equals event dot which. Now it's very, I don't particularly like this way of programming. I mean, event.which, what does that mean? It doesn't make sense. But that's the one we have to use. And basically, all we're asking is store into key code what key is being pressed. And I'm going to finish that off, as with every JavaScript sentence, finish that off with a semicolon. So now we've got the key code, we can ask what is that key code, and if it's the right one, do something. So I'm going to, on the next few lines, well, I want to compare the key code with a number. I'm going to say if, and I'm going to open a bracket, and this is where we put the conditional for the if. What happens, what triggers this if? And we want to say if the key code is equal to some number, and that number represents a key on the keyboard. So if key code equals, and then I need to put in the number for the key that I want to press. So let's say I'm moving the donut forward. Let's say I use the arrow keys. Let's say I use the up arrow. I need to put in there, I can't just put in up arrow, it won't work. It doesn't know what up arrow is. JavaScript has given a number to up arrow. And the best way to find that out is using a little known website called Google. You literally open a new tab and search JavaScript key codes. And you can find a website that tells you. This one I found to be all right. It gives you a table and it tells you the key code of every key on the keyboard. So we can see that the up arrow has a key code of 38. The down arrow has a key code of 40. The left arrow is 37 and the right arrow is 39. I will just stick this website in chat if anyone wants it. If I can remember. There we are. But we need to put the key code for the up arrow, which is 38. Is it? Yeah, 38 for up, 40 for down. Left is something, can't remember. We'll get there in the end. So if the key code is 38, which represents an up arrow on the keyboard, close rounded bracket. And because this is an if statement, and because this is JavaScript, we have to put everything that belongs in the if statement, we need to put it between two curly brackets. So I'm going to open a curly bracket here. And then on this line is where I can do what happens if I press the up arrow. I want to translate the player, so I'm going to write player dot translate. And then I need to choose a direction. Let's call Z forward. Let's say Z. And let's, like before, open a bracket. Type how much we want it to translate. Let's do 0.5. Then close the rounded bracket. Finish it with a semicolon. And then, on the next line, we can close the curly bracket. The error goes away, and we are good to go. So let's go over what we've done. We've got an event, and this happens when the key is pressed down. If the key down happens, then if that key, the one that was pressed, was number 38, then we can translate player in the Z direction. I'm going to close the script and I'm going to click play. And we should see that if I press the up arrow, the character moves, my donut is moving. But if I press something else, like let's say number 3, nothing, space, nothing. I'm mashing my keyboard, and it only works if I press the up arrow. Right, now that's in place, we can do the other keys. Let's use this, let's go back to scene. Let's scroll down again, and let's edit the code. Oh, I need to stop the game first. It won't let you edit things if you don't stop it. So we've got what happens if the key code is 38. But what happens if it's the down arrow, which is key code 40? Well, I'm going to do exactly the same. I'm going to write if key code equals, and the key code for the down arrow, which is 40, close bracket, open curly bracket, player.translate z, because this is going backwards. But hang on, if I put 0.5 in there, the character's just going to go the same direction. I needed to go the other way. I needed to go backwards. And as with lots of these game engines, as with Scratch, as with GameFruit, as with Unity, Blender, Unreal Engine, you have positive takes you forward, negative takes you back. So I'm going to have that as a negative number. Negative 0.5 minus 0.5. I'll finish that with a semicolon. Make sure I close off the if statement. And when I click play, let me zoom in a bit on that. When I click play, I can move the character forward or backward. Forward or backwards. I'm going to press stop. And as you can imagine, doing left and right is quite easy. I can just copy this bit of code and I can paste it. But I just need to change the key code. So we can have left, which is 37. And we don't want to translate in the Z axis. We want to translate instead in the X axis. So where it says player.translate Z, I'm going to change that Z to be an X. Okay, I can do the same again and change that 40 to a 39 and change the Z to an X. Okay, let's play that and see what happens. I could go forward, yes, backward, yes, left, yes, and right, yes. Righto. So we've had a fun little experiment with creating a moving character, but I said at the start I didn't want to make that. I wanted to make a 3D first-person dungeon crawler. And it's basically a maze that you navigate and you see it as if you're the character. At the moment, we're just moving a character around. We don't actually move a camera around, which is what we need to do. In 3D games, everything is to do with cameras. Cameras are what the user sees. And what we're seeing actually at the moment is this camera here, which is the editor's camera. This is for when you're actually making the game. It's not for actually using in the game. So we need to add our own camera. So I'm going to go ahead and click Add. And scroll down. And let me zoom out a little. We can see at the very bottom of the add list, we've got two options for cameras. We've got an orthographic camera. We've also got a perspective camera. Now, an orthographic camera is for making isometric games. It's very freaky. It's great for making lots of weird art that's impossible. Search up the game Monument Valley. It's an excellent example of an orthographic camera. We don't want that. We want to use the perspective camera. So I'm going to click perspective camera. And it's given us, I'm not sure whether you can make this out on your screens, but it's given us sort of this point in the middle with 4 lines sticking out of it. And basically, whatever's inside these 4 diagonal lines can be seen by the camera. Sorry, I just moved it in the Z direction, didn't mean to. Okay, so at the moment, the camera is in the floor, as is everything that we add to this scene. Let's move it out of the floor. So I'm going to move it up in the Y direction a little. And now we can see that it's inside the donut. I don't want it inside the donut. I'm going to move it out of the donut a little. We can actually view what the camera's seeing at the moment. Now we've added a camera, we can see that this drop-down box in the top has added the perspective camera. And this is what the camera sees. I can't control it anymore, but this is what the camera in the game is actually looking at. I can change it back to the editor's camera in that drop-down box again. Okay, so one last thing we need to do before we start fiddling with our code. We need to give this camera a memorable name. Because otherwise, I mean, perspective camera, that's its name at the moment. It's a little confusing. Let's call this camera Tony. Yeah, Tony. Tony the camera. I mean, you could call it something sensible, but it's Thursday. It's close enough to Friday. I'm having a bit of fun. I'm going to call my camera Tony. Now we've got the camera Tony, we can actually go back to our code and we can change how the camera behaves. So if I scroll up and I find scene again, and then scroll down to script, I can edit the script that we've got called level logic. And you see that we've got the player as being whatever the character object was. Maybe I don't want to move the character anymore. I want to move the camera. And I called the camera Tony, so I'm going to replace where it says character, I'm going to replace that with Tony. And we're going to move the camera around and the camera is called Tony. Let's click play. And it seems that we've broken it. Nothing's happening. Let's click stop again. The reason behind that is the game is still using the editor's camera as the thing to look through, as what the player sees. We need to tell it to use the Tony character. So I'm going to press enter. Sorry, I've just seen something. This might throw an error. We'll see. We might need to rename a couple of things. I might have been too hasty calling my variable player, but let's see if it works first. Let's say player dot set camera. Notice I use a capital C. Zoom in on that. Set camera, and we need to tell it what camera to use, and we're using the camera Tony. And remember that we set the camera Tony to be player. This is why I was a little bit, I wasn't thinking ahead. I should have called my player something else. I shouldn't have called it player. These two are different things. Whoops, sorry about that. Maybe call it something else, like, I don't know, Susan. Remember that you'd have to change it down here as well. It's all a mess. Let's see if it just works as player. It might do. That's me not thinking ahead. Silly me. Anyway, player.setCamera. And we're going to set it to player. And hope it understands that it's the right player. And I'm going to finish that with a semicolon. Yeah. When I publish the code at the end of this stream, I'll have changed that to be something more sensible. So ignore me. Let's see if that works. Oh, no, it doesn't work. It's crashed. Oh, it's badly crashed. Yep, okay, let's change it. Let's change that. Silly me, I should have been paying attention. So I'm going to change the variable here to be something different, like Susan. Choose a more sensible name. And then I need to change these ones down here. I need to change every translate. So Susan. Change that one to Susan. 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 So the reason why this has caused an error is because player is what appears to be, oh, I need to change it here as well to Susan. Player is what appears to be a reserved keyword. So in every language, you have some words that you're not allowed to use as variable names. Things like function, things like key down. These can only be used for the function, and they can only be used for the key down. Like, I can't have a variable and call that variable if, because if is a reserved word. We can see it's gone purple. So player was a reserved word, and by calling my variable up here, player, it said, player, set yourself to player, and basically the game imploded. This should work better now. There we are. It works fine. And if I move around the keys, I can see that I can actually control my camera. Oh, where's the donut? There's the donut. Let's go for the middle again. That was fun. There we are. Okay, so we can move the camera around, but you may have noticed that was what we call a strafing camera. It was moving left and right. It wasn't turning left and right, which is much more how modern games play. They allow you to turn the camera rather than move the camera. It's like when you're playing a first-person game. The left stick, if you're using controller, moves your character left and right, and up and forward and back. And the right stick changes their view. We want to do the turning part that's on the left and right of the right stick. So if you remember, this was our code for the left arrow. Rather than translating the x coordinate, I want to change the rotation about, because this is the camera, I want to change the rotation about the y. I want the camera to rotate like that. So what I am going to do is, in the script, I'm going to delete that line entirely, and I want to access the rotation. I want to access the rotation of the camera that I've renamed Susan. So I say Susan. And to access the rotation of Susan, I say Susan dot rotation. You can change, when it comes up with these handy little menus, you can hover over something, it tells you what it does. And if you press enter, it writes it out for you. That's a nice little trick. That's a nice little trick that makes a lot of things easier. We want to change Susan's rotation, but we only want to change it in the y-axis. So the dot rotation keyword references all three axes. I want to only change the y, so I say dot rotation dot y. And that gives us access to the y rotation. Now, this is a number, so we can add to it and we can take away from it. So if we want to add rotation, we want to make Susan turn clockwise, I think? Yeah, clockwise. But to add rotation, we need to use the symbol plus and equals. I would go on as to why, but we're running out of time. Basically, it's to stop you having to write out Susan.rotation.y equals Susan.rotation.y plus something. Plus equals is just a a shorter way of writing that whole thing out. We want to do Susan.rotation.y plus equals and some small value. I'm going to do 0.1. And as this is the end of a JavaScript sentence, I'm going to finish it off with a semicolon. And when I press the left arrow, we should move our camera. We should have it rotate. I'm going to do exactly the same for the right arrow. I'm going to write Susan.rotation.y because we're changing y. But I don't want to add. I don't want to add this time. I want to take away. I want to move in the other direction. So rather than plus equals, we're going to use minus equals 0.1. And of course, ending every sentence with a semicolon. Okay, let's give this a go. Let's click play. So let's double check. Can I move backwards and forwards? Yep, I can. I can go through the donut. Can I move left and right? Yep, there's left and there's right. And say that I'm turning left and right, I'm not moving left and right. If you're finding that your controls the wrong way around, you might have to fiddle with some pluses and minuses. You might also have to change the axes that they are moving around. But I can actually turn around and look at the back of the donut. Ooh. Okay, that's enough messing around. We can add some things to make this even better. Just before we finish up, let's close that down. And let's actually add in a little bit more maze-like things. So let's clone that. And let's move it that direction. And this is me just being very lazy. Of course, I'd make these a lot smaller because, as you can see, they're sticking out. The more objects you have in your scene, the slower it will be. Let's have a horizontal one. Let's clone that, and I don't know, there, and then let's edit clone. Yeah, that'll do. It's not the most difficult or pretty maze, but it's just nice, something nice and quick and easy. And you'll notice that we've now got some extra walls. You'll also notice that you can walk through them, which is not great. It doesn't make a maze all that difficult when you can just walk straight through the walls. It's not very useful for us. That's a little bit more involved. That's quite a difficult thing to set up in any game engine. When it comes to Three.js, you have to use something called ray casts. And you have to do something like var raycast, no, var ray equals new raycast. It's a mess, so I'm not going to touch that for now, but it's a great thing to look into if you're looking for extensions. Another quick extension we can make, something that makes it a lot more fun and a bit more like a game and less like a tech demo, we can actually add in some sprites. Now, in a 3D game engine, a sprite is a 2D shape that always faces the camera. So I've just done add sprite, and if we have a look at it, we can see it's this white square And no matter where I turn, it always appears as a white square. We don't see the side of it. We only see the front of it. If I go over to the material of this sprite, and I go down to this map option here and click this grey box, I can actually, oh, not that, please don't edit that, there you are. I can actually give it a sprite. Let's choose something. This is just from an old code club. I've added it as a map, and as soon as I click this, we can see that I've now added a character into my game. It's something terrible I drew just for one code club, but there it is. If we press scale, we can scale it up. And when we press play, we can see that we've now added a character into our game. It doesn't move or anything, but if you're a fan of old retro games, this is how they used to do Wolfenstein and Doom and all sorts of old engines like that. You know, Chex Quest and all sorts. A sprite just always faces the camera. One final thing, just to really polish things off. If I go up to this background option here, we can see that at the moment we've got a black background, and it looks a bit dim, it looks a bit dark. If I change that background to color, I can make it white, or I can make it blue, I can make it green, I can make this horrible kind of sickly gold. Let's choose white. There we are, that's much nicer to play around in. You can actually tell what's shadow and what's not. But I can actually add another effect. If I press stop, I can add in fog. If I click the drop-down arrow next to fog and choose linear, and I change the fog by clicking that little option there, I change the fog to match the color of the background, and I change these numbers represent the distance of the fog. So a large number means the fog's very far away. A small number means the fog is very close. I can change that to be, let's change it, let's say 25. When I press play, we can see that we've now got fog in the maze. And it looks quite atmospheric and it can be quite scary. You know, imagine you're around a corner and there's just a picture of a chicken, like that one. If I go back to the background options and I change that to black, and I change the fog to black, and let's say I move the chicken, let's change that to a large number like 25, yeah. Let's say I move the chicken into the scary corner. If we avoid the donut, we'll now find that we've got what is effectively a horror game. You're navigating a dark maze at night, and suddenly, bam, there's chicken. Anyway, it's a little bit of fun, and it's a great place to start off learning about some of the concepts that make up 3D gaming. It's quite a tricky thing to master, but it's an easy thing to pick up. It's a great opportunity, and these skills will translate over into any 3D engine, whether it be Armory, Unity, Unreal Engine, which is what Fortnite's built on, CryEngine, Amazon Lumberyard. They're all free, and they are brilliant for picking up how to make a 3D game. Anyway, I hope that's been enjoyable. And as always, I'll stick around for a bit if anyone wants to ask me any questions. You can ask on the Technocamps website, technocamps.com, or just in general, just get in touch through Discord, through chat. I hope that's been enjoyable, and have a very good evening. See you around.